Curiosity turns 13. The story behind the singing rover, a Mars milestone, the day Curiosity stopped singing its own birthday tune. On August 5, 2012, NASA's Curiosity rover touched down on the red planet, marking the beginning of an extraordinary journey. But it was the following year that truly captured the world's imagination, when the rover serenaded itself with a rendition of Happy Birthday. This quirky celebration went viral, turning Curiosity into more than just a rover. It became a beloved space explorer with a personality. The humanization of space missions is a common practice, and Curiosity's birthday serenade was no exception. The rover, equipped with no microphones or speakers, used its sample analysis at Mars (SAM) unit to create the musical vibrations. The SAM's ability to produce music was discovered long before Curiosity's launch by Florence Tan and her husband Tom Nolan, both Curiosity engineers. Nolan even wrote a script to play Twinkle Twinkle Little Star. In 2013, ahead of Curiosity's first birthday, the team tested the Happy Birthday commands on a SAM twin on Earth. And with the approval of lead scientist Paul Mahaffey, Curiosity sang to itself. But here's where it gets controversial. Curiosity only sang once. Yes, you read that right. The memes and jokes about Curiosity's lonely birthday celebrations on Mars are based on a one-time event. And this is the part most people miss. Curiosity's singing was a one-off, not an annual tradition. The reason? According to Tan, there's no scientific gain from the rover playing music or singing on Mars. Curiosity is nuclear-powered and has a limited lifespan, estimated at a minimum of 14 years. Every action consumes energy, and as time passes, scientists must be more selective about the rover's activities. Singing Happy Birthday simply isn't worth the energy expenditure. So Curiosity continues its silent exploration of Gale Crater, once an ancient lake, unaware of its missed birthdays. This raises a question. Is it sadder that Curiosity sang to itself, or that it only sang once? We invite you to ponder this and share your thoughts in the comments. What do you think about Curiosity's one-time birthday song? Should it have been a tradition? Or was it better as a unique moment in space exploration history? NASA's Curiosity rover learns new tricks for Mars exploration. Imagine giving an aging robot on Mars the power to multitask like never before. It's the kind of innovation that could change everything we know about planetary exploration. That's exactly what NASA engineers have pulled off with the Curiosity rover, teaching this seasoned explorer new skills to do even more with its precious energy reserves. But here's where opinions might split. Can these upgrades really squeeze more science out of a machine running on an ever-diminishing fuel source? Maximizing every drop of power, why it matters. Recently, Curiosity journeyed into an area on Mount Sharp marked by a strange, cell-like lattice of rocky ridges. Scientists think underground water sculpted these rugged landmarks billions of years ago. Why is this important? Investigating such formations could help answer one of Mars's greatest mysteries. Did life ever exist below the surface while the planet was still wet? The hope is that by studying these geologic clues, Curiosity may reveal whether ancient Martian microbes had a chance to thrive before Mars became a cold desert, an idea that's fueled debate among researchers for years. But this scientific detective work comes at a high energy cost. Curiosity must crawl over rocks, maneuver its robotic arm to analyze minerals, and power up a suite of sophisticated tools, each thirsty for electricity. Unlike its predecessors Spirit and Opportunity, or even the InSight lander, which depended entirely on solar panels, imagine the panic when a dust storm blocked the sunlight. Curiosity uses a radioisotope thermoelectric generator, RTG, a gadget running on the steady decay of plutonium. This lets the rover ignore day-night cycles and weather changes, keeping the lights on no matter what. However, it's not a perfect solution. As the plutonium slowly breaks down, charging the rover's batteries takes longer, shrinking the energy budget available for science each year. Here's the controversial part. Is the RTG slow fade a ticking clock for Curiosity's most ambitious goals? The smart multitasking breakthrough. Traditionally, Mission Control maps out each of Curiosity's workdays with a strict step-by-step task list. One job at a time, an efficient approach, but not necessarily optimal for squeezing the most out of limited resources. Since 2021, NASA engineers have dared to ask, what if Curiosity could safely handle 2 or even 3 jobs in parallel? After all, why not have the rover beam information to orbit while it moves, adjusts its robotic arm, or snaps photos for Earthbound scientists? Testing revealed the answer. With careful planning, Curiosity can multitask without risk. This means heaters and high-power instruments spend less idle time switched on, trimming the total energy spent and potentially enabling the rover to get more science done in a single Martian day. But here's the kicker that often goes unnoticed. Engineers programmed Curiosity to decide for itself when it's finished early. Rather than sitting idle until a prescribed bedtime, the rover now puts itself to sleep if it finishes tasks ahead of schedule. Why does that matter? The sooner Curiosity goes into rest mode, the less time is wasted and the less recharging will be required for the next busy day. Even shaving 10 or 20 minutes off a single activity can, over months and years, stretch the rover's operational lifetime, a clever trick to prolong the RTG's usefulness for groundbreaking research. Facing challenges, inventing solutions, Curiosity's longevity isn't just a credit to its power source. Over time, the team at NASA's Jet Propulsion Laboratory (JPL) has continually tackled mechanical setbacks with a spirit of relentless innovation. When wear and tear threatened the rover's drill, engineers reimagined how samples are collected, sometimes using entirely new methods. If a camera component jammed, creative workarounds ensured that stunning panoramic images still made it back to Earth. Then, there are the wheels. Battered by sharp Martian rocks over 35 kilometers of rugged travel, engineers developed new algorithms to adjust the rover's driving routines and lessen the toll on its metal treads. Some might worry that this damage could soon spell the end for Curiosity, but testing and experience suggest the rover can keep rolling for years to come. Though there's plenty of room for debate. Should NASA push Curiosity until its last wheel fails? Or is it better to switch focus to preparing the next generation of Mars robots? All these adaptive measures ensure that, despite its age, Curiosity continues to act almost as nimbly as when it first landed on Mars. And the stakes are high. Every enhancement, every line of code, every bold experiment keeps the mission active and the discoveries flowing. What do you think? NASA's continued success with Curiosity sparks a fascinating question. Is it better to keep upgrading veteran explorers to extract every possible insight? Or should we shift resources toward deploying new, cutting-edge technology? Do you believe these multitasking upgrades will lead to fundamentally new discoveries? Or are we simply buying time as the clock winds down? Let us know how you see Curiosity's legacy, and whether the risks of pushing old hardware are truly worth the rewards. Jump into the comments and share your perspective.